Okay, so we're going to be talking about 3.5. It's a little bit more on like software testing, and more specifically, we're going to be talking about code coverage. Code coverage is an exciting static verification method, as we now understand how to correctly categorize it, and it's largely focused on. We need a mechanism to tell how much our tests actually test. You know, because like you can write a lot of tests, but like how do you tell how? Like if I say to you, how thorough does your test? You say, well, we have 20 functions, and then you say, oh, we have 1,000 lines of tests. It's like, what does that even mean? You know, like does that actually mean anything? You know, is that what we call a vanity metric? Isn't it? It's a measurement, but it means nothing. Just looks nice. None of this is for iteration 1. This is all for iteration 2, so don't freak out. But what we're going to talk today about is coverage. Coverage of tests. And then code coverage, and then pi coverage. How do we know if our tests are good? How do we know how much our tests test? Well, that's a relatively open-ended question, and the answer is coverage. And there are two types of coverage you can look at when it comes to tests. You have your test coverage and your code coverage. Your test coverage is a little bit more qualitative. It's how much of the feature set is covered with tests. And this is basically what you are doing in iteration 1. You are like looking at the feature set, you know, you're counting them on your hands and you're saying, yeah, we tested that, tested that, tested that, tested that, tested that, tested. Like you're like, yeah, we tested all these things. Great, done. That's test coverage. You know, it's testing. Think what the coverage of tests you have is. It's often left to human judgment, and it's again exactly what you've probably been doing in iteration 1. And when you get marked by your tutor as part of the manual marking they do, they'll also look at your tests and just make a judgment on your test coverage. Be like, yeah, does this cover the feature set? Yeah, it looks pretty good. The more interesting one of what today's about, though, is code coverage. And this is more quantitative. It can be automated. It can be reduced to numbers. And it's a measure of how much code is executed during testing. So you have your, you run your code. Actually, I'm sorry. Just as a quick point, I rewrote some of these lecture slides for this term because I wanted to improve on a lot of stuff. I think I just realized too that in our slides here, we've mentioned that code coverage is a form of static verification, which I don't think is true. These ones are still static, but this is a form of dynamic verification. I think. Anyway, like I think I might be wrong there. I think I just put that in the wrong spot. This will make sense what I'm saying at the end, and we can discuss at the end. But it's like code coverage is a measure of how much code is executed during testing. The reason I say it's a form of dynamic verification is because typically how you determine code coverage is really quite simple. You run your tests like PyTest, so it is probably a form of dynamic verification. And whilst your PyTests are running, you actually just look at how many lines of your implementation are actually being executed, right? Because like code is just, you know, just follows a flow, it just executes line after line. So if your tests, all of your tests together, result in you executing every line of your implementation, you could argue that that's 100% test coverage because you've actually literally quantitatively tested all the lines of code, or more specifically, your tests have gone through every line of code. So there's no hidden use case that you haven't dealt with. In terms of code coverage, we can actually automate this with Python using a library called coverage.py or pi coverage. And what this does is it actually measures our test coverage as a percentage of the number of statements or lines, as you might understand it, executed. This gives us a good indication of how good our tests are. And most importantly, it tells us what things haven't been tested because it can show us what lines have not had our tests run through it. And therefore we're like, that's a blind spot. So you could think of this like removing, it's not something that eradicates bugs, it's something that tries to remove blind spots in your testing. And the reduction of blind spots will correlate to a reduction in bugs as well. So in terms of checking code coverage, we can do this ourselves pretty easily. I'll give you an example. Let's write a really simple program together. So I'm just going to do this in the same, I'll do this in a separate folder. But let's make a file here. I'll go back to, I'll call it CC for code coverage. Create. And I'll make a file here called I don't know. Grade. I'm sorry. I mean, some of these things I don't intend to go into detail, and I'm like, oh, let's do an example. This feels right today. So I'm going to create a function called grade, and it's going to take in a number, you know, and like it will keep it really simple to start. The function might say, you know, if number is less than 50, return fail, and if number is greater than 50, you know, return pass, like this. Now, obviously, we shouldn't write our implementation before our test, but, you know, bear with me here. I'm going to make a file called grade_test.py, and it's just going to be a simple file. It's just going to import, you know, from grade, import grade, def test fail, assert that grade of 40 equals FL, assert that a grade of 30 equals FL, if 20 equals FL. Sorry, I'm just making a note for myself. Okay, so there's our test. Now we can run those tests. You know we can run those tests. You've done this before, hopefully by now. So I'm going to go into my CC folder, and then I'm going to run PyTest. It'll run grade_test.py, and it says it passed. So it did pass. However, does this work? Like, how's the coverage of this? And this is where we can use PyCoverage. So to use PyCoverage on your local machine, if you did the pip3 install for the course, this should work. If you have issues, post on the forum. But on CSE machines, this should work for you. The command we run is this. Now, what this command does, what this command does is it runs coverage. Think of coverage like the eyes. It's like, you know, the eyes emoji, right? Emoji eyes. It's like this. It's like literally just watching it. Coverage is watching it. Coverage is watching your code. And what it's doing here is it's saying, I want you to run all the code in the current directory. Source equals dot is a way of saying this directory. And this is just the run command, right? Like git push. It's like coverage run in this directory. And then we give it -m pytest. So -m pytest, you have to understand that coverage is not an extension of PyTest. It's actually a tool that just tracks coverage, but it can take in a particular testing program to use. So this is the coverage program that is running, and it's using PyTest as like the underlying thing, checking things. So this is like run coverage. We're going to use PyTest to test it, and then it produces an output that looks exactly like a PyTest. It's totally the same. So the coverage has been run. That part's easy. Now what we need to do is we need to actually get the report. So if you copy and paste coverage report in CSE here, now that we've run the coverage, and I run coverage report, you'll actually see it gives me the information about coverage. And it actually tells me here a few things. It says grade.py and grade_test.py. So because of how the coverage thing runs, it tends to run all the files in a given directory, or a directory and subdirectories. What this means is that in your coverage report, all of your test files will be there, and probably all of your implementation files will be there. All of your implementation files will have a coverage between 0 and 100%, and all of your test files will probably have a coverage of 100%, because you ran your tests, right? Like PyTest runs all your tests, so naturally it's going to have full coverage, but you don't even need to worry about these lines. Now, what is coverage again? Coverage is us tracking as a percentage the number of lines in a file that were run through. So you have a file like this, and you see here we have 5 lines, and clearly what's happened is it's gone through the function line, it's gone through the if number's less than 50, and it's returned FL. So in all of our tests, we never actually ran this part of the code. There's 2 lines there out of 5, so 40% of our code was not covered. Therefore, our coverage is only 60%. Now, you can look at this also in a more detailed way by running coverage HTML. And coverage HTML, what it does is rather than just giving you a little output on the terminal, it will actually export this to a folder called HTML_cov in your directory. Now, if you're doing this over SSH or VS Code stuff, you might not be able to open this very easily. It's really hard to support 100 different systems, but what I'd probably say is, you know, to look at the HTML stuff, you probably either want to run it on VLab, you either want to run it locally completely, or if you're using like SSH VS Code, what I would probably do honestly is that I would, if I was using SSH VS Code, I would do it all locally, but I would open VLab just to open these files. So because you kind of need to open them up in a web browser. There's other ways you can solve it, different for different people, but let's actually open this up. So what I'm going to do is I'm just going to open this up in Firefox. I'm going to open up html/index.html, right? And what this will do is this will open the coverage report. The coverage report in HTML is kind of like the coverage report on the terminal. It looks exactly the same, except you can actually dig deeper into some of these things. So you can go inside of grade.py, and if I go inside of grade.py, it will actually tell you what lines you did not run through. So in this case, it says you did not actually run through lines 4 and 5, right? Okay, cool. Well, this is good information for you, so you can now go back and actually test your code, or like improve your tests. So you say, oh, we forgot to test the pass case. All right, def test pass, assert that grade 50 equals pass, and assert that, grade 100 equals pass, or something like this. Easy. And now we can run our coverage again. So we run coverage, we run coverage, run, then we run coverage report. Oh, assert. Thank you. Yep. Oops, that's not what I wanted. Coverage run. Everything passes. Oh, everything passes. Why does that not work? Test grade is pass. Assert that. There's something wrong here naturally. None. Ah, okay. We just found an edge case anyway. We didn't deal with, yeah, exactly. We didn't deal with the greater or equal then. So that's really easy. So now we could, go back to our terminal. We could run coverage run again. Oh God, sorry, VLab's being real slow for me today. Coverage run, and then when we do coverage report, you'll see that we actually get the full 100%. Cool, so we got 100%. Easy, that's all coverage is. It's quite literally a program that looks at your PyTests when they run, and it tells you how many lines of code were run. Easy. This is going to be part of your pipeline for iteration 2, and for some of your labs this week as well. So that's important because you want your code to function correctly. This is actually really useful. I don't think you probably need to stress about this for iteration 1. You can worry about it if you'd like to, but generally speaking, I'd say you're probably pretty safe to leave this alone for iteration 1. So don't even worry. But that's all coverage is in a nutshell. It's actually a really straightforward concept and very powerful tool. I have a couple of examples here that we can run through as well. Though the last thing to kind of talk about conceptually is branch coverage checking. So one argument that people make is that here's the problem. If you have a piece of code and that piece of code does something like, say you have def function that does something, and then you say if a pass, and then you say if b pass, and then you say else print like this, you do something like this. You've got a I'm not saying that you have a program like this, because this is a stupid program, right? But here's the problem with here's kind of one of the concepts of testing. When you test code, what tends to be a problem is not that you didn't run certain lines of code, but rather that you didn't explore certain branches of code, as in you didn't go into an if statement, or you just didn't explore a certain kind of narrative of the code. So the problem with statement checking is that if you look at a piece of code like this, it has 24 lines, but if you just test the else statement, if your code only goes through that, your coverage in terms of lines of code here is going to say something like that it's 80% covered. But in actual fact, someone would often make an argument that you've actually only covered a third of it here, because you have 3 branches, 3 different ways your code could go. Or maybe I should make this like an elif or something. So sometimes what's good, and in fact it's so good that this is actually what we're going to do as part of your pipelines, this is what we do as part of your pipelines, is that we do branch checking instead of statement checking. So if we come back to this code here, right, and we do another check that's like, return pass if it's greater than, if it's, less than 65, say, and otherwise we'll return credit. If we run this one with coverage again, actually, because all the lines are the same thing, it's all, let's just put in some useless print statements here to keep the example simple. You'll see here that if I run this with, actually, let me put these in a different spot. Right, so we run the coverage, we get the coverage output. It's going to say something like, sorry. It's going to say something like that we've got some high amount of coverage. Probably 80%, I don't know. We run coverage report. Oops. I just ran that again twice, sorry. Okay, coverage report. It says 83%. Okay, but we don't want it to be like statement checking, because that's like a bit of a false positive number. So now let's, what's the command? It's like dash branch, dash dash branch. So now when we add the dash dash branch command to it, we get 100% still. Now it says 72, right? So this is like roughly a bit over a third. It's kind of like, well, there was just parts of your code that you didn't explore, and you've roughly explored 2/3 of it, right? And you can go dig into the report and stuff. And who said this? Like Hussein says that, you can also, oh, sorry, not Hussein. Blake said you can also get more detail about what went wrong by just doing the -m. It's not as visual. Like the HTML is super useful if people like the visual, which some people do. Otherwise, you can get more information on the coverage report. And Masoni1 says, so should we be using dash dash branch all the time? Yes, but I don't want to give you the impression that you have to do something because we write the pipelines. So in actual fact, it's kind of like you will just be required to use dash dash branch because it's going to be baked into all of your lab CIs, and it's going to be baked into your project CIs for iteration 2. So, but also like that's just how we determine the mark. Like if you were to not use branch checking and get 100%, it's still 100%. You know, like it's not like one is a totally different output. It's just they give you different indicators as to how you're performing. But most of you are going to want 100%. Let's really look at one quick example. Maybe we won't go through that example, but this is a nice little example, the leap year example. I'll create a file called leapyear.py. Then we'll create another file called leapyear test.py, and we'll copy and paste this code for the isLeapYear function. Great, and then we'll import it and start testing it. Right, so you know from leap year, import isLeapYear, and then we'll have say def, leap year test1. Don't call things test1. This is just because these are small little examples in the lecture. Or let's say, let's give them proper names. Let's say leap year test. Like what do we know about leap years? Well, we test like every 4 years or something. 4 years. Or like standard. So let's test some standard years like leap year. Test leap year, non-leap year or something like this. And this one will say test leap year 4. So the non-tests are pretty easy. We can say, well, let's assert that, well, like 2001 is leap year, 2001 was false. We know it's not a leap year, right? 2003 was not a leap year. 1913 was not a leap year. Any odd number we know is not a leap year. So we write these tests. 1901, etc. Now we want to test if every 4 years is a leap year. Okay, so we say, well, we're going to test, is 2004 a leap year? Is 2008 a leap year? Like this. So we write a few tests that way. So now we can go and run coverage on this to actually get a sense of how our implementation is being tested. We can actually run this in the same folder. It just runs everything. It's just how coverage works. And you'll see here that, okay, so now our leap year function has 57% coverage. So I could, coverage HTML. I'll open this up in the browser. We could have a look at the file. So leapyear.py. Okay, well, we can see here that what's happening is that we are entering the first two cases. Okay, so the first case says, if the year is not divisible by false, if the year is not divisible by 4, return false. That makes sense. Else, if the year is not divisible by 100, return true. Okay, I see why that's happened here, because 2004 is not divisible by 100. So, great. Okay, that also happens. What's the next thing it's expecting, though? The next thing it's expecting is that we check if the year is not divisible by 400 and we need to return false. Okay, so this describes the situation where every 400 years, so if we mod 400 and the remainder is not 0, then we need to return false. So what kind of test do we need to write here? How do we plug this gap? How do we go through this line of code? Someone give me an example of what year you'd want to test to actually pass that particular check. That the year when divisible by 400 leaves no remainder. That it leaves a remainder, sorry. $2,000? Okay, let's try 2,000. So we'll say assert is leap year 2000. I mean, 2000 was a leap year, right? Is that people's memory of it? It's my memory of it. Some of you were born after that date, you children. How many of you were born after 2000? Probably a lot of you now, actually. Right? Yeah, a lot of you would be. Okay, so our test coverage went up. Great. I can run coverage HTML. I'll open up my web browser again. Refresh the page. Okay, so what's happened here is that we actually so someone said let's test 2000, right? But the problem with testing 2000 is that it is divisible by 400 without a remainder. So we didn't actually enter that particular loop. Now people are saying we should test. Oh, everyone's okay. Everyone in this lecture appears to be born in 2002. Okay, damn, crazy. 2001. So you guys missed out on the 20th century. It was a really wild place there for a while. Okay. Test leap year other. So what's missing here, and let's follow the code, is that we entered 2000, but here's the thing. If you enter 2001, right, it's just going to get caught here. Or enter 2002. I'm not saying that was what your suggestions were. So we need something that ends in a 0, is divisible by 4. Okay. We need something that is divisible by 100. I'm guessing. Oh, this stuff always racks my brain. I know what the example is we need to use, right? But it's describing it's blowing my brain up. Max Ewan says if you're asserting a function return as true, you can simply put the assert function, or a false return, you can put the not function. That's totally true. I'm pretty indifferent about that. I've started to develop a habit of liking to write it out like this because I think it's just easier to read personally sometimes, but that's much of a muchness. Kaushik says 2100. Oh, okay, let's try that one. So let's try the year 2100. And what do we expect this one to be? False or true? Let's go with false. Let's go with false? I can't remember. Is it false or true that we expect it to be? Let's just start with false and go there. Let's actually get the coverage check working first. B-Lab's so slow. Just while I'm running this, to answer, someone asked a great question before, which was, I glossed over it because I wanted to chat about it later. It was, Blake said, is it good to test with loops to cover a bunch of cases, like for I and range, etc.? So, the short answer is no, and I when I said I took some notes before, I was actually referring to that, because I realized there's probably actually one thing that's missing. Because we haven't formally got it in the slides or anything, I don't think we're going to put too much emphasis on it. Well, we're not going to put any emphasis on it in iteration 1. We might for future iterations, because, you know, we want you to improve your testing, but testing is a somewhat counterintuitive process where you actually think, oh, well, I would like to make my code elegant. So you think, I'll use for loops and if statements and stuff, but in actual fact, you need to remember that your tests that you write are also error prone as well. Your tests could have errors in them, and the second you start doing if statements and for loops, you've got branching, you've got potential fence post errors and stuff. So contrary to kind of what people might think, what I did with grade test was actually the right thing to do here. You wouldn't want to put this in a for loop. I know it's tempting. I know, like, we all know what it's like. We're all programmers, but it just complicates your code. So ironically, your test should actually be, generally speaking, as simple as possible. Most of the complexity you're probably going to add would be in the form of fixtures, but I would stay far, far away from for loops and if statements. Generally speaking, it's like, and I know there's a bunch of you right now that have done a lot of that, and you're like, oh god, but just don't worry about that for iteration 1. Learn about that for the next iteration, you know, because the next one's due in many, many weeks. So just take that feedback on board for the next iteration and try and actually clean that up. So Masoni says, so tests should be hard-coded then. Oh, I mean, that's such a broad brush statement. What I'm saying is that I don't think you should have for loops and if statements in your tests, because it keeps your tests simple, and keeping simple, logically simple tests is a good idea. And you can solve a lot of problems with fixtures and maybe helper functions. We're probably okay with you writing helper functions for your tests, but again, all I would say is that you should just, generally speaking, not have any for loops or if statements. For loops, while loops, if statements, else statements, anywhere in your tests, right? Again, that doesn't matter for iteration 1. Don't stress out. Keep doing what you're doing, but just take that advice on going forward. And it's because you will write tests that don't work, or they might compile, but they got bugs in them, and then you have to write tests for your tests, right? Because just because you write tests, it doesn't mean your tests work. But it's this ironic inceptive principle of it all. So that's why we have these principles, because someone's got to write the dumb, stupid, inelegant code sometimes. No, I don't want to call it totally inelegant. You know, a little bit more inelegant code, because it's easy to this is so much easier to read and check if it makes sense than a for loop. Even though, again, your little programming brain goes, it's a for loop, there's repetition. It's that's true, but who cares? It's tests. These things are meant to be robust as hell. They're not meant to be, super elegant. Save that for your implementation. So, just to tie off this example, and then we'll wrap up coverage. We ran coverage. Coverage report. I actually don't know if you need to run coverage report before HTML. I actually just don't know. I've never tried it. If that's a necessary step. And now you can see that our leap year has gone to 100%. Okay. So normally it would be good if you could actually sit down and try and normally when you look at a leap year example is actually sit down and understand it, but you can see the power of coverage here, because previously we weren't actually testing some of these cases. So you can use coverage to make sure you're testing everything. To wrap up this particular lecture, you can have a look at this example in your own time. Honestly, this one's a fun one to go around. I mean, if you want some more practice with coverage, then you could try and run coverage against this one and actually try and test it. So days into years is a function that given a number of days from January the 1st, 1970, say, 10,000, 30,000, return what year we're in. So, if you gave it 100, it would say we're in 1970. If you gave it 400, it would say we're in 1971. There's a bug. Sorry, I don't know if there's a bug in this code. I don't think there's a bug in this code, but this is an example of a complicated function that you need to do some some proper testing on, because otherwise you're going to miss a specific edge case. Last comment, and then I'll answer a couple questions, and then we'll wrap this one up. So code coverage is useful. It's more important to look at what's not covered. That's really important. That's why the HTML or the line breakdowns are useful. Branch coverage is more accurate, so we should use that because it gives you a better indicator as to how you're progressing. And yeah, that's the main thing. So if you could leave some feedback for this lecture, that would be great, just while I answer Siri's question. So Siri says, how do we write tests for functions that don't return anything? That's a good question. A function will typically do one of three things. It will either modify the parameters that are passed in, kind of like, pointers in C, right? It'll modify it'll modify a parameter that was passed in. So you could check if what you've passed in has changed. Alternatively, it will return something. So you could check if it returns the right thing. And then third thing is it'll have side effects, which are things where, clear v1 is a really good example of this. You can test if clear v1 works if you successfully register someone after you clear, that you've already registered. So you could register, clear, and register, and if that does not fail, your clear probably worked. Again, this is what I mean about black box tests. They don't guarantee things work, because there's a chance it just works by accident. But yeah, that's the answer to that question. And in terms of your question, Vincent, so to confirm, we do not need 100% code coverage for iteration 1. No, you don't need it. You don't need it. Wait, there's no code coverage. There's no pylint in iteration 1. Pretty much everything we talked about this week is not part of iteration 1. Coverage is a part of iteration 2. I'm not going to talk about it today because you'll see it on Monday, and we can talk about it next week because we have time to talk about it next week. But in iteration 1, your formula was your tests for the auto marking was your tests v your implementation times by our tests v your implementation. In iteration 2, this is just a bit of I really just want to tease this out. It's going to be your test versus your implementation times by our tests versus your implementation times by your tests coverage to the power of something, which we'll talk about this next week, but I'm just trying to conceptually give you a sense, or plus pylint. That's the formula I think we picked up on. It's all written in the spec. You'll see it next week. But the point is that for iteration 2, we will be including your coverage as part of your marking. And that's important because what we're saying to you in iteration 2 is it's not just enough for you to pass your own tests. You need to have tests that test everything. But again, we'll talk about this next week. So this is just to give you a sense of where this is heading. I'm sure some of you have questions. I just don't want to answer them now. And Joshua says, are we going to be using the code from this iteration in the next iteration? Yes. I mean, you could rewrite it, but generally, it's a major project. It's technically a 50% assessment. There's just some milestones where we clock and sort out marks. Cool. So anyway, thank you. Leave some feedback. Just in terms of wrap up, because we're going to do a short 5-10 minute bonus lecture at the end of this really quick before 11. But just in terms of wrap up this week, I'll send out a notice on Friday with tons of summaries about next week and iteration 1 marking and everything else. Art Smart says, do tutors check commits of other non-master branches while marking? Usually not. They usually just go through your master code. Iteration 2 information is coming out Monday afternoon. Shortly after you submit iteration 1, we push the change to your repo. Joshua says, so does that mean we'll have to go fix our code from this one then? Yeah, if your code doesn't work, you will have to fix it up, yes. But most groups are mostly okay. Occasionally there's one group who didn't do anything for iteration 1 and we have to figure out what to do with them, but that's literally one group a term. Okay, cool. Well, thank you. That wraps up code coverage.